Life for me before he started a treatment was very, very stressful. It was unbelievable. He used to wander. He would go through cupboards. He would, it was just, and he would have temper tantrums, and it was very, very, very difficult. It was very stressful.
Yeah. That's it.
Yeah, it's better now, right?
Yes.
Yeah, it's better.
Yes.
Yeah.
Yeah.
Much better, right?
Much better.
I'm gonna tear up now because it was so awful before.
Yeah, I guess. Yeah.
It seems with dementia you don't see I guess you see everything right, but you don't feel everything right.
This study that we're involved in is a feasibility study, so it's relatively small, but it is a randomized controlled study.
With the treatment, I feel a lot brighter. Nothing's dull anymore. I can look around and nothing's dull.
It was a complete change. He became calm. He stopped wandering. He was able to sleep at night, and he stopped searching for everything.
Essentially what we're doing is evaluating the patients at 3 points. Baseline, where are they before they start treatment? Halfway through treatment at 6 weeks, and that at completion of treatment at 12 weeks.
And then she told me that I had to give it up.
Hello everyone, my name is Lew Lym. I am truly looking forward to taking you on this journey of understanding, healing with light. At the end of this journey, you will take away 3 things: an understanding of the healing power of light, how it works, and how you can use its power to heal yourself and others. As an example, I will show you its potential to address Alzheimer's disease. Now let's get into this lecture. Today, this healing process with light is called photobiomodulation. Photo means light, bio means the biological system, and modulation is associated with change and alterations. It is progressively replacing the long-standing label of low-level light therapy and is part of this exciting field of photomedicine. In this lecture, I will often mention red and near-infrared light, which are parts of the light spectrum that are most relevant to photobiomodulation. It's because it is this range that have been found to cause our cells to go into a healing process.
Photobiomodulation helps your body to use its own ability to heal more effectively. Have you noticed your body can heal on its own? It can overcome the common cold and repair wounds. We will show you the way to enhance this capability with light. But first up, let's look briefly at how photobiomodulation began.
Actually, it was an accidental finding that Andre Mester discovered that applying red photons or red light to wounds that were not healing well would make them heal better. And he was actually trying to cause skin cancer. And he had 2 groups of rats, and he shaved all the hair off the backs of each group of rats. And he was going to have an experimental group where he's going to shine this red light, this red laser, and he's going to see if he can cause skin cancer. And then he has the control group, and he's not going to do anything to them. Well, surprise, surprise, all the hair grew back twice as fast on the back that had received the red laser light. And he said, oh my goodness, this is a beneficial effect. It's never going to cause skin cancer, it's going to heal wounds. And so that was the beginning of an accidental finding. And from then on, people were off studying why is the red light effective to help the cells.
Many important experiments in photomedicine are now carried out in respected research institutions in North America, including Harvard Medical School, Boston University, Stanford, MIT, Texas, and the University of Toronto, as well as top institutions around the world, including in Russia and China, where a lot of discoveries are being made. Today, you'll find light therapy devices in chiropractic clinics for pain reduction, in dental offices, in hospitals for cancer treatments, in veterinarian hospitals for many applications, and in homes where they are used for treating winter depression and other conditions. The power of wearable photobiomodulation therapy lies in what it can offer you: effectiveness, no major side effects, affordability, ease of use, and most of all, light energy that is natural. Light powers life. It is that fundamental. Understanding how our bodies react to light enables us to utilize that knowledge for healing. Evolutionary biology tells us that life on Earth began nearly 4 billion years ago, as a few connected molecules responded to light from the sun. This response included the production of nucleic acids, the precursors of the DNA that carries genetic codes for every form of life. Over billions of years, these molecules continued to harness photons, or quanta of light energy, to proliferate into cells and form bigger and more complex organisms.
The study explained the signaling that takes place when the photons are delivered to the cells, resulting in a healing process. More of this later. Now at this point, you might be asking yourself, why have you not heard of this form of therapy if it has such promise? Good question. There are no big marketing dollars for photomedicine because simply there is no company the size of the pharmaceutical giants. However, interest grows because the science is plausible, the evidence is growing, and most of all, people who have benefited are spreading the word. One of those people is Dr. Michael Hamblin of Harvard Medical School. Dr. Hamblin is one of the most esteemed thought leaders in the world of photomedicine and probably has more published books and peer-reviewed articles with his name than anyone else in the world in this field.
I can easily tell you what excited my interest initially in photobiomodulation. I was doing a lot of research in photodynamic therapy. So there you use light plus photosensitizing dyes to kill things. You want to kill cancer cells, you want to kill bacteria, you want to kill undesirable tissue. And when you do these experiments, you have to have a light alone control, okay? So it's usually red light, because that excites the photosensitizers. So you put red light alone, and you find that's doing exactly the opposite of photodynamic therapy, PDT. So it's not killing things, it's actually stimulating them. So once you do these control experiments a few times, you sort of can't ignore it. I mean, a lot of people in the PDT field assume that light alone does nothing, right? It's like negative control, but it actually does do something. And then once you see that, you can study it. So that's how I got into it. Once you see that shining low levels of red or near infrared light onto tissue has a positive effect, which is not what intuitively you would expect. You would expect it to have no effect, right? It's just light. Once you see it does have a positive effect, then scientifically it becomes very intriguing to see what's going on.
Let's now delve deeper into the mechanism of photobiomodulation to understand how and why it works from the cellular level right up to the systemic levels. Let's begin with the mitochondria.
Mitochondria are the energy factories that exist within almost every cell. They are the key to photobiomodulation. Mitochondria have a substance called the cytochrome oxidase that can absorb red and near-infrared light and convert the energy into a form of biological energy called adenosine triphosphate, or ATP. What is ATP? Essentially, it acts as a signaling molecule that leads to healing and tissue repair. The process also generates a mild-level oxidant, reactive oxygen species, abbreviated as ROS, which is another signaling molecule to start the action of transcribing genetic factors that lead to tissue repair. Some people identify this as a redox signaling molecule. This is where physical healing can be accelerated when you introduce red and near-infrared light.
There is another important molecule in the picture, nitric oxide.
Nitric oxide can be a major factor that contributes to cellular dysfunction. If it sits in the cell, it clogs the respiratory chain. So what is the respiratory chain? The respiratory chain is the process that leads to generating ATP. It is the core of the mitochondria. Low-level red and near-infrared light actually frees the nitric oxide back into the body and restores the function of the respiratory chain. Then it takes on an important wide-ranging role of improving nerve function and improving blood circulation by relaxing the blood vessel walls.
The cellular mechanisms are complex, but we can summarize the key players during photobiomodulation.
1. Cytochrome oxidase, the substance that absorbs light. 2. ATP, for cellular energy and signaling. 3. ROS, mild oxidant that signals for cellular repair. 4. Nitric oxide, which when released by the photons, improves cellular functions and has a healthy impact on the central nervous system. It will also help to relax the blood vessels and improve blood circulation. Cells respond to the photons when they are functioning below par, or are not in homeostasis, or in a balanced state.
Therefore, light energy is only selectively used when needed. There is a built-in check and balance to ensure that there is no overstimulation. That is provided that the light energy is kept low. That is why for many years the process is called low-level light therapy.
When the cells respond collectively, the effect becomes systemic. The body goes through a negative feedback loop, which means that whenever it gets a negative feedback in the system, like something is not working properly, it responds by correcting it to meet its set point of optimum health. This loop continues until the problem is corrected as far as possible.
With this going on, photobiomodulation has been experimentally and practically shown to make a healing difference in the immune system, the vascular system, endocrine system, where the hormones are controlled, and of course, the brain. Let's now take a look at a difficult condition like Alzheimer's disease. In Alzheimer's disease, we lose cognitive functions because the disease significantly shrinks the brain over time. This we know.
There is no consensus on how Alzheimer's disease is developed. The most widely followed is the amyloid hypothesis, which proposes that beta amyloid is the primary causative agent for Alzheimer's disease. These plaques are toxic to brain tissues. Many critics believe that it is merely a biomarker that is created by the disease. Other hypotheses include those that relate to the deficiency of the neurotransmitter acetylcholine, the tau protein abnormalities which lead to the formation of neurofibrillary tangles, oxidative stress on the mitochondria, intake of metals such as aluminum and copper, herpes simplex virus, environmental pollution, myelin sheath breakdown, and a few more. For someone who has already developed the disease, the best that existing pharmaceuticals can offer is to temporarily restore cognitive function, usually for about 6 months to a year. This is not a reversal. There is still nothing on the horizon for the estimated 40 million people around the world who've been diagnosed as having Alzheimer's disease or alternative forms of dementia.
Now, what if we just forget about being fixated with trying to attack the biomarkers and symptoms and just trust the body's intelligent response when we help it by directing near-infrared light to the neurons? So let's actually look at the science related to photobiomodulation, specifically relating to the brain and Alzheimer's disease. I have already explained that cells are able to harness light energy for survival and propagation. And neurons are just another form of cells, complete with the necessary structures that enable them to do the same.
Impaired neurons respond positively to near-infrared light. There are several published studies that demonstrate that damaged neurons restore their structures after irradiation with red and near-infrared light. Not just on cells in experiments, but also on laboratory rats with Alzheimer's disease. Neurons damaged by oxidative stress, which is the basis of one of the hypothesized causes of Alzheimer's disease, has also been found to recover in a similar fashion after irradiation with near-infrared light. Now, if you subscribe to the amyloid hypothesis, this therapy does indeed reduce amyloid beta protein as well as the precursors. It mitigates the damage of the disease and improves cognitive functions.
There have been a range of studies carried out with directing light to the brain in the form of transcranial photobiomodulation.
Researchers at the University of California, San Francisco just discovered that stem cells become neurons in the presence of persistent light energy. This is the basis to hypothesize that if stem cells are present in the brain, the regular presence of light energy in the brain could result in new neurons.